All right, guys, one thing before we get started, forgot to talk about filling out your table of contents with you for 1.4, so we need to do that. 1.4, Reasoning and Proof, was on pages 16 and 17. And while we're here, today's lesson is 2.0, Representing and Describing Transformations. So that's going to be on 18 and 19, okay? So go ahead and fill that out. I forgot about that. I will forget about it very often, so yeah. All right, now let's turn to pages 18 and 19. 18, as I said, is 2.0, and it's 2.0 because it's stuff we need to talk about transformations. Representing and describing transformations. Now, this lesson is just a whole overview of transformations, which is nice to see them all together. But if you're confused at all a little bit today, I want you to remember that we're going to have a lesson on each one individually in the next couple of weeks. For once, we are now going to be on a path of learning about the same type of stuff for a while, which is really going to help you out. In the beginning, because there's so many things you need to learn preliminary, I cannot speak today. In the beginning, it's a little all over the place. So to get started, we're going to write some definitions down. So on 19, we're going to talk about what a transformation is. A transformation is a function that changes the position shape and or size of a figure. A transformation is a function that changes the position, shape, and or size of a figure. If you remember from Algebra 1, you should have done transformations of lines and stuff. You shifted them up and down, left and right. They flipped over stuff. That's what we're going to be talking about. I want you to highlight the word transformation. I'm going to highlight in blue. Okay. All right, next, a figure that is used as the input of a transformation is the pre-image. So a figure that is used as the input of a transformation is the pre-image. The key word there is pre-image. The output is the image. So in algebra, input and output, x and y, we got pre-image, image. And the key word here is image. So we're going to highlight image. So we go from the pre-image to the image. And you're going to see more of what that means in a minute. All right, now I need you to tear out of your book, page 32. You don't have to write this down. I'm writing it down. I'm going to blue right over that. 32, 33. 33 might be on the back of 32. Let me check before I tell you to tear out 33. Get my little book here. It is not. Tear out 32, 33, and 35. Now that you have those torn out, and I know that the video probably went bleep bleep, there were some technical issues. Now that you have those torn out, we are going to cut from page 32, B and C. And we're going to cut the rest of it out later. We're not going to cut it all out at the same time here. So we're going to cut out B and C. I'll show what I mean in a minute. Here's B and C, and mine's going to hang off the page a little bit, but that's okay. I'll teach you how to fix that. So we got B and C. We'll worry about the rest later. See, mine sticks out a little bit. I'm actually just going to cut that off. It's not going to matter. I don't have to add those extra lines if I don't have room. If yours ever sticks off too much, you can just take it and fold it up, and that's fine. But glue this in on page, let me focus it. Okay, glue that in on page 18. We'll get the other stuff later, so just keep it to the side. So that's 32. We'll get the rest of that stuff later. All right, so we're talking about transformations. There are different types of transformations. There is a reflection, a rotation, a translation, a dilation. A reflection literally flips. You're probably used to that one. A rotation rotates. A translation just moves up to the side or something, or down into the left. And a dilation makes it either bigger or smaller. So those are the 4 types of transformations. And like I said, we're going to have a lesson on each later. So this is just an overview. So you've got the pre-image, what you start with. You've got something called a rule, and then you've got the image. So we're going to see what's going on. Most of the time, we're going to skip this step. We're going to know the rule, but we're not actually going to work with it through there. So just to let you know, these little arrows, when I read them, they mean maps to. This is a rule. So what we are going to do is find out what happens from the pre-image to the image by regraphing it. So I have my pre-image points written down. The rule says I take my x and I make it negative. Well, negative x, negative 4, it makes it a positive 4. The rule says I don't do anything to y, so write 3 down. Same with s. Negative means it's now a positive 1. Y is 3. Negative 4, 4, 1. These are my new image points. I'm going to graph them to see exactly what happened. Okay? Something you should know, you see how these are RST and these are R prime, S prime, T prime. When you do something to a set of points, transform it, for instance, you need to change them till you put primes on them. And we're going to do that when we graph it as well. So let's graph letter B. I'm going to graph R prime, S prime, T prime. All right, 4, 3. That is R prime. Okay. 1, 3. S prime. 4, 1. T prime. And then connect these. I want you to use a straight edge. I say, as I'm not using a straight edge, use a straight edge. Okay. Here's what we need to do. Now that we've graphed it, we should try to figure out exactly what happened from here to here. Like I said, we're normally going to skip this because most of you can go from here to here without having this written down. And in a minute, we're going to skip that and not do that. Okay, so this says the transformation is a reflection across what? The x-axis or the y-axis? And in case you've forgotten, x-axis is horizontal, y-axis is vertical. So where did this reflect over? It looks like it reflected over the y-axis. So that's what we're going to circle. A comparison of the image to the pre-image shows that this is the same size. They are the same size and shape as it should be. We'll talk about that more in a minute. So we're going to take a pre-image, use the rule to create the new image, and we'll decide what exactly is going on between them. Let's do letter C. Okay. Pre-image. We're going to list these points, reading them from over here. The pre-image, J is at -1, 2. K is at 2, 2. L is at 2, -4. Okay, now here's why we're going to skip this in a minute. This rule part is just copying it back down, and I feel like that's a waste of your time. I don't like to waste your time. For this one, we're going to do it. Okay, so the pre-image to the image is take xy and multiply the x by 2, leave the y alone. -1 times 2, or 2 times -1 is -2. Leave y alone. 2 times 2 is 4. Leave y alone. 2 times 4, 2 again is 4. Leave y alone. Now we're going to regraph it. -2, 2, j prime, 4, 2, k prime, and 4, -4, l prime. Use your straight edge to graph. Now we're going to decide what happened. It says the transformation is either a horizontal or vertical stretch by a factor of blank. So I told you there's 4 types of transformations. There's translation, which we'll talk about tomorrow. There's reflection, which we will talk about the next 2 days, Wednesday and Thursday. And then there's rotation, which we'll talk about next week. There's also dilation. We actually don't talk about that till like almost after Christmas, okay? We'll talk about it here, but then after that we don't talk about it for a while. A dilation means that the x and the y multiplied by the same number. That didn't happen here. Here, it stretches, but it got wider, so that is a horizontal stretch. This factor comes from this number right here, 2. Just to make a little note here, a horizontal stretch is x. A vertical stretch, you see this? Yeah. Is y, meaning a number multiplied by x, a number multiplied by y. A dilation is x and y got multiplied by the same number. So like it would have said 2x, 2y. Okay, that's a nice little note you need at the bottom of your paper there. So a comparison of the image to its pre-image shows that they're now different sizes. So we're going to talk about the difference when sometimes we have some that are the right size and sometimes we have them that are different sizes. Okay. Scoot over to page 19. Definitely got the page wrong. 19. You're labeling it 2.0, representing and describing transformations. We're going to write on that page. A rigid motion is a transformation that changes the position of a figure without changing the size or shape of the figure. Okay, once you have that written down, we're cutting something off. Drop my straight edge. We're cutting something off of page 33. Cut this off of 33 and glue it in right here. Remember that I kind of move kind of fast in the video because you have the ability to pause it. Okay, so I just keep going. So properties of rigid motions. Rigid motions preserve distance, meaning the lengths of the sides are the same. Rigid motions preserve angle measure, so the angle measures are the same. When I say the same, I mean like between these two figures, the distance between RS and R prime S prime are the same. The angle R and R prime are the same. Rigid motions preserve betweenness. We'll talk about betweenness a little later. Rigid motions preserve collinearity. So in RS, they are collinear. Well, R prime, S prime are collinear as well. Rigid motions preserve parallelism. So if you had two things that were parallel and then you moved them over, they would still be parallel. All right, we're going to talk about rigid and non-rigid. There are three types of rigid motion. There is one non-rigid. We've seen the non-rigid already. Rigid are translation, reflection, and rotation. Non-rigid is dilation. That's why we actually talk about dilation a lot later, because we group it in with a non-rigid similarity kind of thing, which we'll talk about later. We normally just talk about these for now. We will have some of this today. All right, next, page 35, you need to cut out 5 and 6. And yes, you need the directions as well. You're also going to need your calculator, which means I need to get mine. Okay, so cut this from page 35. Get my calculator while you're cutting that from page 35. Okay, I didn't glue it. Let me glue it. Okay, 5 and 6 say use coordinate notation to write the rule that maps each preimage to its image, then identify the transformation and confirm that it preserves length and angle measure. Okay, just to make sure you understand exactly what each part of the instructions mean, we are going to highlight the instructions. First step, use coordinate notation to write the rule that maps each preimage to its image. We're going to do that right here, and I'm going to box in what that looks like. So here's what I got to decide. I've got to look at these and see what happened from here to here, and make sure it happens for all of them. I am starting with x, comma, y, and that maps to something. But I got to decide what's happening from here to here, okay? I went from -4 to +4. Okay, maybe it's just a negative. Is that what happened here? 2 to negative? Yep. Negative to positive? Yep. So I'm swapping. I had negative, positive, negative, and I went to the opposite. That means I'm just going to put a negative in front of the x. Let's find out what happened to y. Negative, negative, negative. Oh, that's cool. It just so happens that it went to negative. I took my points and made them negative. This is the coordinate notation rule. That's what it's discussing. You will do the same thing on 6, and you're going to pause the video and try that later. Okay, let's go to another color. Then, identify the transformation. Identify the transformation. My options are translation, reflection, rotation, or dilation. I know it's not a dilation because this compared to this does not look bigger or smaller, okay? So I'm going to rule that one out. So let's think about this. Is it a translation? Did it move up or down? Well, it definitely moved up or down, but wait, if it's just a translation, that means that it didn't like turn or didn't anything like that, but this looks like it probably turned or reflected some way, so I don't think it's a translation. Let's go to reflection. Reflection, remember, means it flips, so let's think about it. Did it flip over the x-axis? No. Did it flip over the y-axis? No. It can flip over this line, but if it flips over this line that you can't see, let me put a pin or something there. Put this little cable here. If it flips over this line right here, E would be where F prime is. So I don't think it flipped there. Okay, let's look at this line. Does it look like it flipped there? No, it'd be over here somewhere. So I don't think it's a reflection. Those 4 that I showed you are the only 4 that we use most of the time. We'll get to reflections later. So the only thing that's left is probably a rotation. Here's what you need to know about rotations. There are 4 options. By the way, we start with D, E, F, and not D prime, E prime, F prime. And yes, that's how you say it. That's like a whole mouthful. Here's how this works. Every time I move to another quadrant, in case you've forgotten what those are, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Every time I move to a new quadrant, that's 90 degrees. Okay, so there's 90 degrees. If I moved it here, it'd be about here with D. Well, it's not there. Okay, if I moved it again, that's at 180, because 90 plus 90 is 180. It would be there. If I moved it a third time to 70, it would be here. So moving at 90 puts it in quadrant 1. Moving at 180 puts it in quadrant 2, which is pretty much where it is. Which means this is probably a 180 degree rotation. A rotation, 180 degrees. I need to say about the origin. Remember, the origin is right here. About the origin. That is step 2. This green information right here. Okay. Next, confirm that it preserves length and angle measure. We're not going to do the angle measure part because literally you take a protractor and just measure all 6 angles. And we're not going to do that part. We're going to do the length part, which is distance. It's using the distance formula. Or remember, you can use the Pythagorean Theorem. Okay, so we're going to do that to show that it preserves distance. Here's what that means. DE should be equal to D prime E prime. And we're going to check. DE right here is 1, 2, 3, 4, 5, 6 units long. Let's go count DE. 1, 2, 3, 4, 5, 6. That one's good. We have to check them all. DF. We're really lucky that this is a triangle that is a right triangle and matches on the lines. If it is on a actual axis, like on the coordinate there, I don't know how to actually say that word, on the line, you only have to count it, okay? DF, 1, 2, 3. D prime, F prime, 1, 2, 3. Good. Now EF. E prime, F prime. Now I'm going to have to use either the distance formula with the points, D and F, or I'm going to have to use the Pythagorean theorem. And I'm going to use the Pythagorean theorem. Here's why. This is already a right triangle set up for me. Okay, guys? So the Pythagorean theorem, remember how I told you guys, I'm going to write over here to the side, it was that C equals the square root of A squared plus B squared, where these are A and B. Okay, so EF is 6 squared plus 3 squared, and we're going to find that. But E prime, F prime, we also have 6 and 3, so that means it's also 6 squared plus 3 squared, which means they have to be congruent. It's the same thing, which means if I don't even want to find the decimal, I don't have to, because if they're the same right here, then they are the same. That's the last step. I'm actually going to find them, though, but that is the last step there. So I'm going to take my calculator. And I got 6.7. Okay. I want you guys to pause the video and try number 6. Do all 3 things here. I'm going to go ahead and keep going because remember, I want the video to be short, but you have the option to pause it. All right, step 1, find the rule. What happened from here to here? This one's tougher. If I've got one that's kind of tough, I always like to find the one that's positive because that will help me more. So from 2 to 3, I add 1. So let's see if that happens everywhere. Is negative 3 plus 1 negative 2? Yeah. Is negative 2 plus 1 negative 1? Yeah. Okay, so let's write it. That means x, y maps to x plus 1. All right, let's do y. And I'm going to start with, I can do this one or this one or this one. They're all positive here, except for 0 that's neutral. All right, 4 to 2, that's subtract 2. 4 to 2, subtract 2. 0 to negative 2, subtract 2. Y minus 2. That's the first part. Next, identify the transformation. Here's a hint. Remember, I'm just going to go back up to this list. First is translation. As a hint to you, save your life a lot. Anytime it's plus and minus, it's a translation, okay? But literally I can look. It looks like S just went over and down. That's what happened. That's the translation. It's a translation. But we have to be careful in how we write what kind of translation happened. It looks like from S to S prime, we went left. I don't know left from right. We went right 1. Right 1 unit. And what else happened? Down 2. Now, guys, look right here. Right 1, left, down 2. Okay, that is the second step. Now we need to see if they preserve distance. Very sad day for us. Only one of these is on the line. So we got to kind of do a lot. That's okay. It won't kill us. Let's start with ST. That's the easy one. And S prime, T prime. I'm highlighting this, by the way, because your homework requires you to do every step. If you don't do it, it's not full credit. All right, ST, 1, 2, 3, 4, 5. S prime, T prime, 1, 2, 3, 4, 5. Good, check, done. now it doesn't matter which one we do next. Let's do SU. S prime, U prime. You're either using the distance formula or the Pythagorean theorem. And I'm using the Pythagorean theorem because I don't like the distance formula if I don't have to. Which means, Pythagorean theorem, I need to draw a right triangle at SU. And a right triangle at S prime, U prime. Okay, SU, 1, 2, 3, 4. And then 1. And then 1, 2, 3, 4. And 1. It's probably going to work out for me. So, 4 squared plus 1 squared. 4 squared plus 1 squared. Now I know they have to be the same, but I'm just going to go ahead and find it. And in my calculator I got 4.1 for both. Check. Done. Last. TS. Okay, gotta make a right triangle. This is why erasers save your life. And I'm sorry, like it shakes me when I erase. Let's make a right triangle at TS. T to S. Not TS. Remember how I told you I make mistakes and then like you gotta help me fix them? If you're watching these and you see me make that big of a mistake, please fix it. It's TU. We already did TS right here in ST. Okay. T to U. Let's make a triangle. And this is 1, 2, 3, 4. 1, 2, 3, 4. Okay, because TU right here is hypotenuse. Alright, if we did it in T prime to U prime, 1, 2, 3, 4. 1, 2, 3, 4. They're going to be the same if the slopes are the same. I mean, not the slopes the size of the other triangle that we made. But let's go ahead and just find it out. 4 squared plus 4 squared. 4 squared plus 4 squared. Five point 5.7. Check. I am now finished with this problem. Remember, I highlighted all this stuff so you would remember exactly or know exactly what each part was asking. You have to do every part that your homework says, except for the angle measure, because I just told you in the video you didn't have to do that. Okay? So get off the video, ask questions if you need to, and do the homework assignment that is written on Google Classroom. I'll see you tomorrow.